In the lesson 2, we will discuss about advantages of SI units and dimensions, dimensional formula, dimensional formulas for certain physical quantities, principle of homogeneity of dimensions, its applications of dimensional analysis, limitations of dimensional analysis. So all the topics, majority of the topics belongs to dimensional analysis, and one topic, last topic, in the last topic, so we left this topic, that is advantages of SI units. So advantages of SI units. So SI system is a coherent system because all the SI system depends on only fundamental units. All the SI units depends on fundamental units. So we have, in the last class we discussed about fundamental units. There are 7 fundamental units. If we know 7 fundamental units, we can easily derive all the units by simple multiplication or division without any complex mathematics. We can simply derive all other units if we know fundamental units. And in SI system, it is also provided multiples and submultiples by the powers of 10, by the powers of 10. So this is also one of the advantage. To measure larger quantities, we are using multiples, powers of positive numbers. To measure smaller quantities, we are using submultiples, 10 to the power of negative quantities. So therefore, it is a coherent system, simple system. We can easily derive all the quant units by simple multiplication and division. So example, force, force equal to mass into acceleration. The unit for mass is kilogram. The unit for acceleration is meter per second square. So here, simple multiplication, mass into kilogram into meter per second square. By using simple multiplication, we can derive unit for force. And some others also. In some cases, we can, by simple division or both, sometimes both multiplication and division. So velocity, V stands for velocity. Velocity equal to distance by time. So the unit for distance, the distance is measured in meters, and time, T stands for time. Time is measured in seconds. So that is equal to meter per second square. By simple division or simple multiplication or both multiplication and division, we can easily derive all other units. So in SI system, we can simply derive all the units. Therefore, it is coherent system. This is one of the advantages. And rational system of units, that means it assigns only one unit to particular physical quantity. For example, joule is the unit for all types of energy. So energy is one quantity, whether it is chemical energy, mechanical energy, solar energy. So it is a one quantity. The for the energy, the unit is joule. But in other systems, in MKS system, so mechanical energy is measured in joule, heat energy measured in calories, electrical energy is measured in watt hour. So all are replaced by simple unit, that is by single unit, that is joule. So it is rational. SI system is rational. Okay. And next one, SI system is absolute system. So the use of factor G is eliminated. Gravitational units are eliminated. So it is a metric system. That means we are using so 10 to the, 10 to the power of. So to in multiples we are using 10 to the power of positive numbers. In submultiples we are using 10 to the power of negative numbers. So to express larger quantities we are using multiples. To express smaller quantities we are using submultiples. And so we are some practical units also we are accepting in SI system. Some practical units are also accepting. So Henry for inductance, Faraday for capacity, Newton for force. They are very familiar units. Instead of writing in fundamental units, that familiar units are also accepted. So it is internationally accepted system. SI system is the internationally accepted system. Therefore, it avoids confusion. It avoids confusion between technocrats and scientists of all the countries. Okay. So this is about the advantages of SI system. So it avoids first advantage is it avoids confusion. It is coherent, and the all the SI units some advantages all we can I have not tried here. I have not written that are they are well defined. The characteristics itself advantages. In the last class, we discussed about characteristics. The characteristics itself advantages. It is well defined. Therefore, it can be easily reproducible. The SI units are easily reproducible. That is also advantages. They are well defined. That is also advantages. It avoids confusion because it is internationally accepted system. So all are the advantages of SI system. The next topic is dimension. So dimension is the power of fundamental physical quantity which is to be raised to get the derived physical quantity is called dimension. To represent dimensions of a physical quantity, all the fundamental quantities are represented by special symbols. So when I am explaining, I will tell you about I will clarify this definition. The power of a fundamental physical quantity. While writing dimensional formula, all these fundamental quantities have given a special symbol when writing dimensional formulas. They are the length in dimensional formulas, dimensions topic. The length is the fundamental quantity length is represented by capital L, mass is represented by capital M, and time is represented by capital T. Actually, so in units, the length is represented by meter, mass is represented by kilogram. That is different. And in dimensions, the mass is represented by capital M. Time is represented by capital T. Temperature is represented by capital K. Electric current capital I. Luminous intensity is represented by capital C. And amount of substance as written as mole. Similarly, in case of units also. These are the dimensional formulas. L is the dimensional formula of length, M is the dimensional formula of mass. So remember these letters to indicate the dimensional formulas of seven fundamental units. And dimensional formula. So dimensional formula is an expression to indicate the given physical quantity. To dimension formula is an expression to indicate okay. Dimension formula is an expression to indicate what physical quantities are depending and how it depends on the fundamental quantities. How a given physical quantity depends on fundamental quantities. So dimension formula, in order to write dimension formula of a given physical quantity, we should know the equation. Velocity equal to displacement by time. So displacement comes under length. Displacement is nothing but length. It is measured in meters. Length is measured in meters, and as well as displacement also measured in meters. So the dimension formula of length is capital L, and dimension formula of time is capital T. So L power 1, T power, sorry, here this is not 0, it is a 1. It is 1. It is 1. So L power 1, L power 1 and T power minus 1. So this is the dimension formula of velocity. So what it indicates that the velocity depends on length, velocity depends on time. How it depends? So L power plus 1, that means the velocity is directly proportional to length. T power minus 1. So minus 1 indicates that velocity is inversely proportional to time. Here these powers L power 1, T power minus 1 are the L power 1, T power minus 1 are the dimensions, and L power 1, T power minus 1, all this equation is called dimensional formula. Okay. Okay. See this. So this is 1 plus 1. Okay. So here the dimensions of length and time of length and time in velocity are plus 1 and minus 1. So plus 1 is the dimension of length. So and minus 1 is the dimensions of time in velocity. In velocity, the dimensions of length is plus 1, dimensions of time is minus 1. So these numbers are dimensions. This whole of this total formula is called dimensional formula. This is dimensional formula, and the powers are dimensions. So this is dimensional formula. This is dimensional formula of velocity. So this is the dimension formula of velocity, and plus 1 minus 1 are dimensions. So again we can revise definition dimension. Now you can understand what is dimension. The powers are dimension. This equation is dimensional equation. See, the power of a fundamental physical quantity which is to be raised to get the derived physical quantity is called dimension. So powers, this power is called dimension. L power plus 1 is the dimension. T power minus 1 is the dimension. So L power 1, T power minus 1. So minus 1 is the dimension, plus 1 is the dimension. The power is the dimension. This total equation enclosed in a bracket. are called dimensional equation. It is clear, I think. What is dimension? What is dimensional formula? So in length, so L power 1 is the dimension, and L is the dimension formula, M power 1. So M power nothing means there is a, that is power plus 1. So 1 is the dimension of mass, and M is the dimension formula. M power 1 is the dimension formula of mass. And similarly, here in time 1 is the dimension, and t is the dimension formula. Okay, this is about dimension and dimensional formula. So the expression which shows how and which of the base quantities represents the dimension. The expression which shows how and which of the base quantities represent dimensions of a physical quantity is called a dimension formula of a given physical quantity. So see here, acceleration. Acceleration, the dimension formula for acceleration is m power 0, L power 1. So L power is nothing means here plus 1. We can consider plus 1. Okay. So m power 0, L power 1, T power minus 2 is the dimension formula of acceleration. So this expression indicates that acceleration depends on length, because m power 0, 0 means nothing, m power 0 means 1. So acceleration depends on length, and acceleration depends on time also, inversely proportional to square of the time. T power minus 2 means 1 by t square, 1 by t square. That is acceleration is inversely proportional to square of the time. So the acceleration depends on length and time. That information is that one information is acceleration depends on two quantities, that is length and time. And how acceleration depends on these two quantities? Acceleration directly proportional to length. If more length we are traveling, that means more acceleration. In less time we are traveling, that means also more acceleration. The expression which shows how and which, so which means on which quantities and how it depends on that quantities. So that expression is the dimension formula. That expression is called dimension formula of given physical quantity. Here given physical quantity acceleration in this example. So this is about dimension formula. The expression how which shows how and which the given physical quantity depends on base quantities. The expression which shows that the given physical quantity depends on base quantities. This is about the dimensional formula. These are some examples, these two. And so dimension formulas of certain physical quantities. See, first one, area equal to length into breadth. So length into length, L square. So m power 0, t power 0. So mld, usually we are writing three di- dimensions. In the dimension formula, usually we are writing three letters, mlt. So simply we can write L square, but we are writing three letters, m power 0, L power 2, t power minus 2. So L power, so the dimensions of length is L, the dimensions of breadth is also L, L into L. So L into L, L square. This is the dimension formula of area. But the unit is different. Meter square is the unit. Next, volume. Length into breadth into height. L into L into L. L cube. Density. Mass by volume. The unit for the dimension formula for mass is capital M. the volume is L cube, because the value dimensional formula of volume is L cube. So m by L cube, m L power minus 3 t power 0 is the dimensional formula of density. So in this way we can derive dimension formulas of all the quantities if you know the equation. If you know the equation. So acceleration, velocity by time. First we, and for this, to derive dimension formula of acceleration, we should know dimension formula of velocity and time. The dimension formula of velocity is L power 1 t power minus 1. So L power 1 t power minus 1. In place of velocity, we can write L power 1 t power minus 1 by time t. So L t power minus 2, L t power minus 1 by t. If we solve this, we can get L t power minus 2. So L t power minus 1, first one, t is in the denominator. So if it comes in numerator, t power minus 1. So L t power minus 1, t power minus 1. So t power minus 1 into t power minus 1. We can, so in this expression we have to add the powers. Minus 1 plus of minus 1, that is t power minus 2. L t power minus. So L t power minus 2 is the dimension formula of acceleration. So in the last column, simultaneously I am showing SI units also. Meter per second square is the unit. L t power minus 2 is the dimension formula. So in the exam, they may ask dimension, write the dimension formula of units. You should thoroughly understand whether they are asking dimension formula or units. So mostly they are asking dimension formulas. So write the dimension formula of density, acceleration, and force. You should write m L power minus 3, L t power minus 2, and dimension formula of force m L t power minus 2. So this is the dimension formulas. And surface tension, force by length, gravitational constant, force into distance square by mass square. So finally you get m power minus 1, L power 3, t power minus. You try in the in home, this one, gravitational constant. So gravitational constant, equation for gravitational constant is force into distance square by mass square. Substitute dimension formula of force. Dimension formula of force. Dimension formula of force is ml t power minus 2. Distance. Distance is nothing but length. So length square, that is L square. And mass. The dimension formula of mass is m square m square. So you can substitute this one and solve, simplify this one. You will get m power minus 1, L power 3, t power minus 2. This is the one of the quantity in which the mass is inversely proportional to the is inversely proportional, m power minus 1. See all the quantities, m power 1, m power 0, m power 1, m power 1, m power 1, m power 1, m power 1. The negative power here, the mass is inversely proportional, is in numerator. This is one of the quantity, rare quantity. Mass is in, if mass is more, gravitational constant is less. Sorry, it is constant if mass is more, and force is less. So gravitational constant is inversely proportional to mass. If mass is more mass, the force is less. Finally, this is constant. Gravitational constant is it is a constant, universal gravitational constant. 6.67 to 10 to the power of 11. So if mass increases, force decreases, but total If mass increases, force increases. So total, this equation gives constant value, that is gravitational constant. Okay, this is a, oh, this information is coming from this dimensional formula. Coefficient of viscosity, moment of inertia, angular momentum, couple. We have to derive all these dimension formula of all these physical quantities based on that equations. Okay. Principle of homogeneity of dimension. The principle of homogeneity of dimension states that the dimensions of each the dimensions of each of the term of a dimensional equation on both sides are the same. It is extremely useful in checking the correctness of given equation. Correctness of given equation. So if we write an equation means it has one term, minimum one term in LHS side, minimum one term in RHS side. This is equal to symbol. If you write equation, it minimum it consists two terms. For example, V equal to U plus AT. This is an equation. So LHS side we have term V, and RHS side we have two terms U and AT. So A into T is one term. The terms are separated by addition or subtraction only. Addition or subtraction only. Here addition, we have one addition, that is two terms U plus AT. AT is one term. So this is first term, this is second term, this is third term. So three terms. There are three terms. So V equal to U plus AT is the equation. One example for equation. So in this equation, all the terms should possess same dimension formula. The dimension formula of velocity and acceleration into time must be same. This is given by principle. This is stated by principle of homogeneity of equations. Principle of homogeneity of dimensions. So all the terms should possess same dimension formula. So the dimension formula of the dimension formula of velocity is L t power minus 1 equal to, and this is final velocity, this is initial velocity. So this is also same dimension formula of velocity is L t power minus 1 plus the dimension formula of acceleration is L t power minus 2. The dimension formula of time is into capital T. So finally L t power minus 1 and L t power minus 1 plus L t power minus 2 into t. Again L t power minus 1 only. So see here L t power minus 1, L t power minus 1, L t power minus 1. So statement, you observe this statement. Each term, each term, the dimension equation should be same. So each term of dimensional equation on both sides are same. This is called principle of homogeneity of dimension. Then only this equation is dimensionally correct. Then only this equation is dimensionally correct. Therefore, this equation is dimensionally correct. So this is about principle of homogeneity of dimension. Simply telling that each term should possess same dimensional formula. Okay. Example, let us consider an equation of mv square. kinetic energy equal to mgh, potential energy mgh, where m is the mass, v is the velocity, g is the acceleration due to gravity. G is nothing but acceleration. Now we have to verify this, we have to verify the equation. For this we have substitute dimensional formula of mass, dimensional formula of velocity, dimensional formula of in the right side dimensional formula of mass, dimensional formula of acceleration, and height. See dimensional formula of number, this number 1 by 2 that doesn't have any dimensional formula, and the dimensional formula of mass is capital M. Dimensional formula of velocity is L t power minus 1 square, L t power minus 1 square. Right side dimensional formula of mass is M, and dimensional formula of acceleration into height, both L t power minus 2 into L, that is L square t power minus 2. So M L square t power minus 2. If you solve this also, you get M. So this is right LHS side. Only we are dealing with LHS side. Dimensions of LHS. So M L power L t power minus 1 whole square. If we simplify this, M into L t power minus 1 whole square gives L square t power minus 2. So L into square and t power minus 1 into 2. L into 2, L power 2, t power minus 2. Finally, M L2 t power minus 2. This is the dimensional formula we are getting in the LHS, LHS side, and RHS side, right hand side. So dimensional formula of mass is M, dimensional formula of acceleration is L power L t power minus 2, and height is measured in length, in measured in meters. Therefore dimensional formula again L. So L into L, L square t power minus 2 same. So M into L power 2 t power minus 2. Finally M L2 L power 2 t power minus 2. So M in the left side M L power 2 t power minus 2. In the right side also we are getting same dimension formula M L power 2 t power minus 2. So the dimensions of LHS and RHS are same. Hence the given equation is dimensionally correct. So this is about principle of homogeneity of dimensions. Applications of dimension analysis. This dimension analysis we are using in three applications. They are to verify the correctness of given equation. To verify the correctness of given equation, first one, and to derive the relation between physical quantities in physical phenomena, and to change units from one system to another system. These are the three important applications of dimensional analysis. So first equation, first one by one in detail, we can check verify these applications. So first one, to verify the correctness of given equation. So speed equal to distance by time, speed equal to distance by time. So the dimensional formula of speed is L t power minus 1, and distance L, the dimension formula of distance is L and time is capital T. So L t power minus 1. So dimension formulas are same, left side and right side. Therefore, this is dimensionally correct. This equation is dimensionally correct. The equation is dimensionally correct as the dimensions of speed is same on both sides. So this is about verification. If any complex, you can verify any complex equation by using, by following the same procedure. S equal to ut plus half at square. So any equation, take any equation, verify whether it is dimensionally correct or not. derive relation between physical quantities in physical phenomena. This is one interesting. This is interesting one. See this. It is helpful to find out the relation between physical quantities. If you know how physical quantities depend on each other, if you know how physical quantities depends on each other. Suppose the time period of a simple pendulum depends on length and length of the thread, mass of the pendulum bob, and gravity, acceleration due to gravity. We only know that information. So time, I think you know the meaning of simple. You know the simple pendulum experiment. So simple pendulum. So it consists a thread and one iron bob. Okay, very good. So this is the so a simple pendulum. A heavy point mass is suspended by heavy point mass is suspended by a thread. So the distance between these two is length, and this iron bob or bob of the pendulum possesses certain mass. When we displace this simple pendulum, it makes oscillations. So it makes oscillations. So it makes oscillations. So it makes oscillation about mean position. So this is length. This is m is the mass. So it makes a to and fro motion. For example, this position is A, this position is B. So mean position is O. So it moves, for example, it moves from A to B and again come back to A. The time taken to complete one oscillation to reach same position A to B again B to A. The time taken to complete one oscillation, two motion. Two means A to B, from means B to A. So it completes to and fro motion. The to motion and fro motion consist one oscillation. We have to find out time period of this simple pendulum, but we don't know equation. See, the time period. The time period of simple pendulum. We are assuming that, simply assuming, the time period depends on length. We are simply assuming that the time period depends on length and mass. If mass is heavy, time period may change. Just we are assuming. And also it depends on acceleration due to gravity. Mg. Weight is acting vertically downward direction. Weight is acting vertically downward direction. So mg. So it depends on acceleration also, acceleration due to gravity also. Three factors: time period depends on length, mass, and acceleration due to gravity. Just we are assuming. And how it depends means we should know dimensions. The dimensions are x, y, z. This is also we are assuming. That is also we are assuming. So t is the time period. Time period depends on x power of length. Sorry, length power of x, m power of y, g power of length. So time period depends on length, mass, g. So Since how we don't know how it depends on these quantities, that is length and mass and gravity. We are writing, we are taking powers: L power x, m power mass power y, gravitational acceleration due to gravity power z, Lg power z. K is constant. Here we have to apply dimensional analysis. Left side the quantities time period, that is time. Right side the quantities are length, mass, acceleration. Length, mass, acceleration. Ultimate aim is to find the equation for time period. Equation for time period. So left side write the dimensional formula of time. Time t power 1, remaining quantities are 0. Remaining, there is no other quantities: m power 0, L power 0, t power 1. Right side, k is constant. L l is the length. L is the length. The dimension formula of length is capital L. So L power x. And m, the dimension formula of mass is capital M, m power y. The dimension formula of acceleration, L power t, L t power minus 2 power z. If we simplify this equation, m power y, L power, see two L's are there, L power x, L power z. So L power x plus z, and L t power minus 2z, t power minus 2 into z, t power minus 2z. So compare two these equations, left side equation, right side equation. Powers. See, m power 0 here, left side m power 0, right side y. That means y equal to 0. Here m power 0, here m power y. That means y equal to 0. Next, L power 0. Left side L power 0. Right side L power x plus z. That means x plus z equal to 0. And left side t power 1, right side minus 2z. Minus 2z equal to 1. By simplifying this equation, minus 2z equal to 1. So x plus z equal to 0, L power 0. So x plus z equal to 0, minus 2z equal to 0. So z equal to minus 1 by 2. If you simplify this also, x equal to plus 1 by 2. So y equal to 0, x plus z equal to 0, minus 2z equal to 1. If we simplify, we get x equal to plus 1 by 2, y equal to 0, z equal to minus 1 by 2. Substitute these values in the above equation, this equation. Substitute that values in the equation. You will get L power minus L power 1 by 2, m power 0. M power 0 is nothing but it is eliminated. See, the time period does not depend on mass. It only depends on length and acceleration due to gravity. It only depends on length and acceleration due to gravity. So L power 2 means square L inversely proportional to. So simply we can write this equation as T equal to K under root L by G. This is the equation of time period of a simple pendulum. Initially we don't know that equation, but we derived this equation. So that is the advantages of dimension analysis. Even though we don't know the equation, we are able to derive the equation. So time period depends on length and acceleration only, does not depends on mass. That means See these two simple pendulums. So here the mass of the simple pendulum bob is small. Here mass of the simple pendulum bob is more. In this both the cases, the time period is same. Why? Because the time period does not depends on the mass. Time period does not depends on the mass. It only depends on length. If length increases, time period increases. If acceleration increases, time period decreases. So this is about the uh, this is about the so to derive the equation depends on the unknown quantities. To derive the equation of unknown physical quantity, here unknown physical quantity. So the time period, we don't know the equation for time period, unknown. So we are able to derive the equation for time period. Okay. So in today's lesson, so we discussed about the advantages of SI unit and the dimension. Dimension is the power of a fundamental physical quantity to be raised to get the derived physical quantity. Dimension is the power. That equation, total equation is called dimensional formula. And the dimensional formulas, how we are deriving dimensional formulas of certain physical quantities. And principle of homogeneity of dimensions. Principle of homogeneity of dimension tells about the that is, if a given equation, the both sides of the equation, the both sides of the terms of the equation should possess same dimensional formula. Should possess same dimensional formula. And applications of dimensional analysis. So in the applications of dimension analysis, we have three applications. In the next class, we will discuss about limitations of dimension analysis. Three applications to verify the given equation, and next, second application to derive the equation connecting different physical quantities. Third application to convert one system of unit into another system of unit. This third application also we will discuss in the next class. This third one to change units from one system to other system, and limitations of a given equation we can derive in the next we can discuss in the next class. So this is about dimension analysis.